So we got an empty rubber balloon. They give us the mass of the balloon. They give us the mass of the balloon. It's filled with helium. We have the density of helium here. And at this density, the balloon, they give us the radius. What else do we have? If the filled balloon is then fastened to a vertical line, what's the tension in the line? So this problem starts with a free body diagram. So you got a visual of what's happening. We got this balloon attached to this vertical line. The rope is preventing the balloon from going up. So we do free body diagram. So here's the balloon. Oh, and by the way, one thing the problem doesn't mention that you have to have. So what's the fluid being displaced here? Air. Like as the balloon fills up, as the balloon gets filled with helium, the fluid being displaced as the balloon gets bigger, 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 air is the fluid being displaced. We're going to need the density of air. Okay, so here's the balloon. What are the forces on the balloon? Well, definitely there's a buoyant force up. Okay, buoyant force up. What is the buoyant force equal to? The weight of the displaced fluid, which is going to be mg for the what? Air. So A is air. Ma is mass of air. All right, now, what are the down forces? Well, the balloon is attached to a rope, and that rope is holding the balloon down, so we have tension down. What else do we have down? mg, so it says right here, they give us, so the mass of the rubber balloon itself is given right here. Just the rubber itself, so we'll put mg down for the balloon. mg, so mass of balloon times gravity, mg for balloon. And then there's one more. Helium. The problem here, it talks about helium. Now guys, what I'm about to do, you're going to be like, no way. And then I'm going to say, way. What do you think of when I say helium? Do you think up or down? You think of up. But look, helium, it's just that helium's lighter than air. The helium going into this, like what if we filled the balloon with water? If we filled this balloon with water, you'd be like, oh, that's down. It's the same concept. I mean, the balloon's being filled, not with water, but with helium. So mg is down for helium. So the question is then, why does the balloon want to go up? Well, check it out. What's going to be bigger, the mass of the helium or the mass of the air? Mass of the air, and that points up, right? But mg for the helium is down. Just think, like if you filled the balloon with water, you'd draw mg down. Okay, so now what do? Now we sum the forces. I'm going to need more room than this. Hold on. I need more room. Let me scoot this over. Shrink this down. Put it over here. That should be an H right here. Okay, so now summing the forces, here's what we get. So we have mass of air times gravity up, that's the buoyant force, minus mass of helium times gravity, minus mass of the balloon times gravity, minus tension, and then all of this is equal to ma, where what would that mass be? That mass is what? That's the total mass of the whole balloon, like, balloon plus the helium, okay? But is the balloon accelerating? No, because it's attached to a rope and it's not moving, right? So the acceleration is 0. So the question wants us to solve for tension. So if you rearrange this, so I'm going to factor the g out. Tension would be g mass of air minus mass of helium minus mass of balloon, right? That's what the algebra would give. So let's circle what we're missing. Or actually, let's circle what we have. We know gravity, and we have the mass of the balloon, right? The mass of the balloon is 0.012. So what do we need to figure out? We got to figure out the mass of the air and the mass of the helium. If you haven't heard me say this, hear it now. Fluids are tedious. So how are we going to get the mass of the air and the mass of the helium? Well, you got to find the volume of the balloon. The volume of the balloon, using this equation, right? What's the volume of a sphere? 4/3 pi r cubed. So you take this radius, plug it in over here. The volume of the sphere comes out as 0.523599 cubic meters. That's the volume of the sphere. Now, guys, what's the volume of the helium going to be? It's going to be that. It's going to be 0.523599 cubic meters. What's the volume of the air going to be? The volume of the displaced air. Is the balloon fully submerged in air? Yeah. So the volume of the air is 0.523599. It's the same volume. So now how do we get the masses? Well, to get the mass of the air, look, take the density equation. Density is mass over volume, so what's mass going to be? Density times volume. We have the density of air, 1.29 kilograms per cubic meter, multiplied by the volume, 0.523599 cubic meters. Okay, so we find out that the, oops, close that. Oh, hold on, dude. Anyway, so you find the mass of the air. Mass of the air comes out as 0.675 kilograms. Do the same thing for the mass of the helium. Right? Just change the density here to 0.181. The mass of the helium comes out to be 0.0947. You plug in up here, the tension comes out as 5.6.